Hi, my name's Josh Bliss. I'm a master's student at Towson University in Maryland. I'm a marine biologist with a particular interest in clonality. It's weird calling myself a marine biologist when I'm originally from the Midwest. I worked with Dr. Maureen Neiman at the University of Iowa, first as a high school intern, and then throughout my undergrad working with a species of colonial snail. I was very fortunate to have a summer internship in 2022 at the FCCF Marine Lab on Sanibel Island, Florida, where I worked on oyster reef restoration and a small side project on a very cool species of sea slug. At the end of my undergrad, I was able to present a poster at a conference in California where I met my current mentor, Dr. Will Ryan, who invited me out to Towson to work with some sea anemones that I'd like to tell you more about now. The story actually starts before I was even involved. This is a boat dock in Virginia that was one of several sites that my mentor was sampling for a different project. At first, the only anemone he found here was Sea Anemones lineata, until the summer of 2020 when he first noted another species I'm going to call red spot. And after that, very quickly saw red spot almost completely take over this site. It's worth noting that these are really small animals that most people don't pay attention to, so it's really likely that if he hadn't been doing this sampling, no one would have noticed this change in community, and I wouldn't have a master's thesis to talk about. So what is my research question? It requires a little more context on these two species. Both are what we call partially clonal, meaning they can alternate between sexual and asexual methods of reproduction. But the way they go about the asexual part is very different. On the left, Lineata performs binary fission, quite literally ripping itself in half down the middle. On the right, red spot does what's called pedal laceration, breaking off small pieces of its foot that will go off and become new anemones. So what if they break apart different ways? Well, this is where Dr. Ryan's previous work comes in. What he found is that binary fission acts as a way to regulate body size in response to temperature. The hotter it gets, the more lineata splits, because to cut a long story short, it's not great to be big when it's hot for something like an anemone. This leaves me to wonder and hypothesize about what the role of laceration might be. If red spot is also getting smaller, this seems like an inefficient way to do it, and if it's not getting smaller, why is it not running into the same problems as lineata? So my goal became to establish the same understanding of red spot's life cycle as we had for lineata. One half of figuring that out was a controlled experiment where I kept anemones at constant temperatures. This seems pretty straightforward in theory until you have to design and build your own equipment to house them, or use existing equipment in ways never intended. And you have to be flexible, say, when the temperatures you want to achieve can't be done with what you have. In the end, I'm very proud of the setup I managed, and of the unique forms of some of my data. Best way to track size was to take weekly tracings of all the anemone feet, and after a while, there were a lot to trace. The other half was seeing what was happening out of the wild through time. So over the course of 2024, I went back to that Virginia site several times and took my own scrapes, spent a lot of time picking through slop like this in order to get an accurate picture of what these anemones were doing. Of course, then all that data needs to be analyzed. For fun, here's some of my grand totals. The lab experiment began with 120 individuals. After 9 weeks, I had a total of 8,117 anemones. While out in the field, after sampling 10 different times, I ended up counting a total of 32,155 anemones. The full analysis is far from being done, but I'm very happy to share some of the general understanding I've pieced together. As it turns out, red spot is not shrinking, at least not drastically, although it does still split more often in hotter temperatures. It does also seem to have a longer window of sexual reproduction compared to lineata, which might begin to explain why they benefit from staying large. There's still a lot more to investigate and a lot I didn't have time to go into, but thank you so much for listening.